Hello. Let's change it. Beautiful slide. Well, TestOps. This term is not widely used, and everybody defines it differently, and we are not an exception. Some people define TestOps as using production system as a test environment. The main advantage is that limit number of exposed servers with exposed users generate a variety of input signals, providing a huge number of possible use cases, which is almost impossible to reproduce in the test environment. However, exposed users pay for quality for others. This approach is acceptable for non-critical and widespread services like social media with millions of users. Most of them do not even notice that they're production testers. Even though a little number of them notice some misbehavior, they suffer for the greater good for others. And globally, all the users get a better service. But is this approach acceptable for exchange testing? Obviously, because of regulatory compliance, we cannot expose real production users, which means that all our production users must be provided with a full and high quality service. And here we end up with our own vision of TestOps environment, which must be fully controlled by us and have the same monitoring and operating instruments as the production environment. We use historical data for results comparison. Because we are not testing in the real production, we cannot, we must simulate the same input from users. For that purpose, we use anonymous production data and update our load accordingly. Testing with artificial data in the lab does not show the real behavior of the system under load in the production. But still, what does the production environment mean? We cannot just recreate the production environment and leave it as is. Should we keep exactly the same configuration and restrict access for testers? Should we be afraid of testers doing things which may break the environment, or should we wait for help from system operators when something goes wrong? What we need is production environment which would add the value 24/7, and the main value for us is obviously the data. When we're talking about availability, we mean that we must have an ability to bring up the system at any time and continue testing. It may crash at any time, unlike the real production environment, which is the part of testing process, obviously. But the software will break anyway, and the absence of adequate monitoring is what turns a problem into the disaster. And having the same monitors as operators doesn't guarantee that we are not missing an issue. Some alerts may not be set up for a number of reasons, at least not to overwhelm the operator. But they must be maybe useful for testing reasons. So we use our own backup monitoring system not only to check messages we found important, but also for automation reasons as well. Another advantage of having the backup monitoring system in our environments is that we can collect the data in the same format, which can be easily stored for future use. The main process flow, in addition to code delivery, consists of 4 main steps. Once the new product build is delivered, all the testing tools and environments must be ready to go. Testing tools and scenarios must be developed and updated in parallel with product they test. A change of production user behavior may reveal a problem we didn't expect. So all the scenarios must take this change into account. The key moment here that we must have an opportunity to change the system configuration gradually to find the potential issue. Whether the change in data or in the new binary or a combination of other factors. To simplify deployment process, we develop this solution. Test cases are updated using data from Jira and immediately uploaded into the version control system. So we always know why the test cases were updated and when. And from our side, all the main tools are uploaded securely into the same version control system by Jenkins. In the client's network, all the data may be collected and managed by Ansible, which is responsible for deployment and environment setup process. And so once deployment is completed, the testing can be started immediately. Since we are always limited in time, the system must not be idle, which is impossible when human run tests. Testers spend time for checking all pre and post conditions. Even more, they spend more time on test executions more than on test improvement. It leads to the testing process stagnation, of course. The standard high-touch testing process makes testers work under the hundreds of conditions they must take into account. The main advantage, though, that they may notice the things as real system operators and rely on their experience or, say, the sixth sense and rerun the controversial test. We obviously need a test management tool which would check the conditions and historical data to decide what kinds of tests must be executed and when. That way, we save human resources and time for test improvement. The ideal solution is the combination of both methods when the testers monitor the system using the tools available for system operators and have an opportunity to compare their observations with the data the automated tool provided. Automated test scenarios must be transparent and user-friendly. Tester is not supposed to write complex scripts and for scenarios execution, which may become a problem for issue analysis. All the logic or the complex logic must be isolated from the end user. Scenario must be executed in a different environments without drastic changes. For that purpose, we have developed a framework for testers. Here's an example of the simplest scenario. You don't need to be an expert to understand what's happening. The idea is simple. An abstract command like exec smoke is what the tester should use. They should not be bothered by thinking of what kinds of scripts they must execute in a particular environment and what kinds of parameters they must accept. Every scenario consists of a sequence of such commands. The interpreter executes all the commands one by one. This is very convenient for semi-manual testing when user can just enter a couple of commands and check the result. It must be said, though, that these commands are quite complex scripts and they need someone to maintain them. The functionality may be extended with plugins written on Python, so where exec smoke command is provided with one plugin and does one thing in another environment, its behavior may be changed a bit. But the entire scenario remains the same. And scenario execution means nothing without a monitoring system. For that purpose, we deploy our own tools to get the actual system status. Since we work in prod-like environment, we want to have a lightweight and system-independent solution. We can simply adapt to our needs. We don't want to rely on system tools and libraries or install our own runtime. Sometimes it doesn't even possible to make changes in the test environments. We run daemon on every test server, which is responsible for logs parsing and real time and gathering system metrics. All the messages are redirected to the router that collects and processes all the data and delivers it to clients. A client, in our case, is the test manager tool itself. The user can analyze data offline using Grafana or any other visualization tool. The script manager itself uses this data to decide whether the next command may be executed or not, or to check a status of a previous command. This slide shows data gathering process. Let's assume that we have a server that runs a matching engine and a system monitoring server, which logs all the system metrics and events. And daemons collect all the system info like CPU usage, disk space utilization, and network usage, and parse system logs in real time. The script manager receives all the data and builds an actual picture. What happens when user enters a command? That all the messages are redirected to a particular daemon, which decides how to execute a command and confirms the command execution status. All the data is delivered back to script manager, which builds an actual picture. And during our failure simulation, in our case, an alert may be raised, or script manager may show that it receives an unknown message from the log. For now, all the required preconditions are defined by users. Alert limits for the essential metrics, system event triggers, and others. And historical data is used for post-processing only when the test is completed. Unfortunately, describing all the possible test input and output signals for result comparison cannot be done efficiently by humans. So we put our efforts into collecting as much testing data as possible for machine learning, which would enrich our scenarios in the future. So thank you.